We have an ideal transformer. Now the way V out is defined plus to minus. See it, plus on the top, minus on the bottom? So maybe I should assign the current I sub 2 is going this way. Because if I assign it going that way, then V out equals what? 2I sub 2. If I assign it going the other way, it's going to be negative 2I sub 2. Now I can find the equivalent circuit and do it, or it's actually, this is two questions. So the first question, find I sub 1. If I'm looking for I sub 1, I could have found the equivalent of this, replace all of that with some equivalent value, and just use one mesh equation. Done. When I'm looking for V out, part 2, I can chop the circuit right here, find the equivalent of this half, and do it, or I can leave it the way it is. So the first way I'm going to do is leave it the way it is. I'm going to have 4 equations by 4 unknowns, but they're not that big of a deal to solve. Let me find the relationship between V1 and V2. Notice V1, the dot is positive in the same direction. Polarity is the same. So V1 to V2 is equal the ratio of what? N1 to N2, which is in this case 1 to 2. It's positive because the polarity is in the same direction. So that tells me what? V2 equals 2V1. I1 to I sub 2, it's N2 to N1, but the question is it positive or negative? It's positive. If one enters the dot, the other one enters the non-dot. If they both enter the dot, it's a negative. You remember that from before. So since this is backward, that's also a plus, which is in this case, that would be what? N2, 2 over 1. That tells me I sub 1 cross multiply equals 2 I sub 2. So there's my first 2 equations, right here. So now if I do KVL to this loop here, to that loop, KVL will call it 1, loop 1. So I get negative 12 angle 0 plus 2 times I sub 1 plus negative 2j times I sub 1 plus V1 is equal to 0.
So like before when we did that, like we had like some m value and stuff.
N is the ratio of N2 to N1.
Oh, like the m value?
Yep.
Like m between the two inductors?
Yep. So they go 1 to A. Is that what you're talking about, the A? Oh, the mutual inductance?
Yeah.
Yes. That's when you have to look at the effect of this on this. With ideal transformer, you don't have to do that. Just write V1 here. Then you're going to see you're going to have 4 equations by 4 unknowns. So right now, if you clean that equation, what do we have? 2 minus 2j I sub 1 plus V1 equals 12 angle 0. So that's equation number 3. Let me put it in a box there. And if I do a KVL here, the second loop right here, negative V2 plus 2I sub 2 plus negative 2j I sub 2 plus 2I sub 2 is equal to 0. Or if you clean that, it says V2 equals 4 minus 2j I 4 minus 2j I sub 2, right? I think that's correct. So notice if you just wrote these 2 equations trying to solve them, you can't. You have 2 equations by how many unknowns? 4. That's why we need these 2. With these 2, I can replace I sub 1, I sub 2 by their values, and I can shrink these 4 equations by 4 unknowns to 2 equations by 2 unknowns. If I take the bottom equation, that's this one, and do some substitution, I know what I sub 2 is equal to. Can you see it? Over 2, right? And I know what V2 is equal to. 2V1. If I do that substitution in this equation, I'm going to have 4 minus 2j. In place of I sub 2, let me write what? I sub 1 over 2 equals, in place of V2, let me write what? 2V1? Do the math. Divide this by 2, that's what? 2 minus j I sub 1 equals 2V1. And what is V1 equal to? 2 minus j over 2 times I sub 1. Now take that and do a substitution in that equation, and you will have one equation by one unknown. Everyone see that? Tom, go ahead. No?
Nope, I got it.
Yep. So I took this equation, and to switch it to I sub 1 and V1, I did the two substitution here. So that's what happened. We shrunk that to this equation. Now I get this and that, which is two equations by how many unknowns? Two unknowns. So I can take that equation, which is 2 minus 2j I sub 1 plus V1. In place of V1, let me put what? 2 minus j over 2 I sub 1 equals 12 angle 0. I'm not really a fan of fractions, so let me multiply everything by 2. By 2, this will be what? 4 minus 2j I sub 1 plus this will be what? 2 minus j I sub 1. By 2, this will be 24 angle 0. 4 and 2, 6. 6 minus 3j I sub 1 equals 24 angle 0. Can we get I sub 1? Angle 0 divided by 6 minus 3j. And I came up with I sub 1 being 3.58 roughly. Angle what? 26.6?
When you multiply that 2,
Yep. Oh, that should have been 4 here, right?
J,
Yep, that should have been a 4. Thank you. That's a 4. Correction on this. Good job, Tom. I forgot this piece. That was 2j. That should have been 4j here. So that's going to make that, what, 5? Six minus 5j, so let's change I sub 1. It's going to change it a little bit there. (24 angle 0) divided by 6 minus 5j. 3.07, and the angle is 39.8. Now, if I know I sub 1, can I find V1 while I'm at it? Take this answer and multiply it by this one. 2 minus j over 2. So times And my V1, if I did the math correctly, 3.44 approximately, angle 13.2. If I know V1 and I know I sub 1, can I find V2? V2 is 2 times V1. I don't need it, but I'm having fun. Let's multiply it by 2. 6.87. I carried all the digits, that's why it's not 8.8. Angle 13.2. And what's I sub 2? I sub 2 is what? I sub 1 divided by 2 from this equation. I sub 1 divided by 2. So let me take I sub 1. 3.07 angle 39.8 divided by 2. And that's 1.53 or 54 angle 39.8. And the last question, because there were two questions. The first one, find I sub 1. The other one, find VO. To get VO, we said V out is what? 2 times I sub 2. So multiply I sub 2 by 2. 3.07 angle 39.8. Volts here. That's volt. This is amp. So that's both of these questions in one shot. Now, the other way of doing the problem, if I'm looking, because the first question was find I sub 1. If I'm looking for I sub 1, and I'll show you that, I could have cut the circuit and Theveninize it basically, find the equivalent of the circuit. If I chop it right here and find the equivalent of that. So, method 2, this is method 1. Same problem. 12 angle 0. Notice instead of writing 2 minus 2j, why not just make a 1 box, call it 2 minus 2j. Make life easy. And I can combine these guys because I don't care about V out. The question, find what is I sub 1. I can take 2 and 2, 4 minus 2j. And I'm defining I sub 2 is going this way. And I sub 1 is going that way. And this is 1 to 2. Our book, I think we use the letter A. What was A? The ratio of, I think, N2 to N1, which is 2 to 1, and that's a 2. I think that's our book used A, I think. Can't remember if it's A or N.
Our book used A.
A? Okay. So if I chop this circuit right here, I should be able to replace this by an equivalent value. So my circuit will look like this. 12 angle 0. 2 minus 2j. There is no sources in it, so just the impedance, the resistor. And I should be able to replace this by a value that's equal. This is ZL here. And it's ZL over A squared. What's a squared here? Is 2. So square it, that's 4. That'll be 4 minus 2j divided by 4. Which is, if you want, 1 minus what? 0.5j? And this is your I sub 1. And this voltage here is V1. Since the question, what is I sub 1? I can use Ohm's law. I sub 1 is 12 angle 0 over the sum of these. The sum, because it can combine these guys into 1. So that'll be 3 minus what? 2.5j. And let's see if that's the answer. 12 divided by 3 negative 2.5j, or I. And I came up with an answer, 3.07 angle 39.8. Quicker, huh? The other one's not really that bad, but I mean, if I had a source, I have to replace the source with Vs over N. I think I gave you that sheet last time. Now, the second part, or the second question is, what is V out here? So this, here we go, let's go back. I'm going to do it with the, find the equivalent. So for the second one, let me put the circuit back here. What is V out? That means if I know I sub 2, I can find V out. So here's my circuit.
But we already know it's 2I2.
Well, if I didn't know this, if I didn't do it this way, this is method 1 without having to find the equivalent. I can actually bypass these 2 pages. And what I did here is a replacement to this method by finding the equivalent of this. That'll give me I sub 1.
Yeah.
So I'm going to show I'm going to find the equivalent. So not knowing this, so this is method 3, or answering question 2 without knowing this one. If I don't know this one, I can look at the circuit like this. I can replace this with 2 minus 2j. I'm going to replace this with 2 minus 2j again. Two here. And I'm looking for V out. This is I sub 2. And this is V out. I can chop the circuit right here and find the equivalent of this part. Because if I do that, I still have I sub 2. That doesn't change I sub 2. If I know what I sub 2, I can tell you what V out is.
I'm just saying, like, you don't even need to do that because we know that V out is 2I2 just by assigning I2.
Yeah, if you know this equation, yep. Once you know I sub 1, if you know this equation, you can do it.
And you already know I sub 2.
Yep,
So.
correct. But I want to pretend I don't know that. None of that stuff. I just want a question was, separate question, not knowing the other stuff. What is V out? Not knowing anything else, you know? So if that was the question, what I might want to do instead of going through this is find the equivalent of this. So the equivalent of this will look like this. 2. This doesn't change. So I'm going to chop it here. So this is really V2, and this is I sub 2, and this is V out. So what is the equivalent of that? This value here will be n squared times, if I call this ZL, So n squared, what's n is 4, times 2 minus 2j, and that'll give me what? 8 minus 8j. And this will give me a value of a source here with the value of n times Vs1. N is 2, 12 angle 0, which is what? 24 angle 0. So here's my circuit, 24 angle 0. I can combine these guys into what? 10 minus 10j. Can I find V out now? Isn't that voltage division? This times that over the sum of these. So let's see. 48 divided by 12 minus 10j. 3.07 angle 39.8. Was that the same answer we did before?
Same answer as that one.
Yep. That's V out.
So minus 10j because you're adding 10 to the 2.
Correct. Notice when we did the other way, we got 30.07, 30.8. So you have a couple options for them. You can treat them if you memorize these, you know. So again, I'll put these equivalent back there for you in case you lost them. If I have a source here, and this is Vs1, source 1, and I have a value called Z1 here. And this is V1. And I have I sub 1 going in, going to the dot here. The dot plus minus V2, 1 to n, and this is Z2, and this is source 2. And if I make I sub 1 going this way, you can always change them if the direction is backward. You can always reverse them by reversing the value for it. That's all you got to do. So if we give you a current going in, make it this way and multiply by minus 1. So you stick with that notation. You will find you can break this one down. If you want to simplify the right side, this will be Vs1 stays the same. Z1 stays the same. This we're going to chop it. And I can replace this with the impedance here of Z2 divided by n squared, or a squared. Would I use n? N squared. Sometimes I use n, sometimes s. And this value, if there's a source here, will be Vs2 divided by n or a. Yeah. And again, this is V1 here. And the current through that, it's actually I sub 1. Because I'm replacing this, so it's I sub 1 going that direction. I divide this by n squared, divide this by n. If I do the reverse there, if I leave the source on the other end, and I leave Z2 here, and I chop it here, then I can replace all of that with a value here of n squared times Z1 with the source of n times Vs1. And this is V2 here, and the current's I sub 2 going through that. So those are the equivalent values. And if you know V1, you know I sub 2, you can find I sub 1. Here, again, just by looking at this, V1 to V2, V1 to V2 is N1 to N2, which is 1 over N. That tells me V2 equals N times V1, or V1 equals V2 over N. So, if you know what V1 is, you can find V2. If you know what V2, you can find V1 from this circuit. The other one, if you look at I sub 1, I sub 2, the ratio of I sub 1 to I sub 2 is N2 to N1. That's N over 1. That tells me I sub 1 equals N times I sub 2, or I sub 2 equals what? I sub 1 over N. So if you know I sub 1, you know I sub 2. If you know I sub 2, you know I sub 1. You can find everything about it. Any other ones?
Can you do the very last one?
What number was that?
10.10.
10.10. Okay. Let's look at 10.10. And I have, I should have left a space there, 10 angle 0, two, two, there's my dot. This is V1. I think it's 1 to 2, if I'm seeing thing. Uh-oh. Plus minus V2.
Wait, did it have the dots on there? Did it show the dots?
Yes.
Okay, I forgot to write them down there.
This is I sub 1 going in. I can't tell if I sub 2 is going in or coming out the way they define it.
I think it's going out of the
Yeah, I think it's
positive.
Coming out? Okay.
Going out of the positive.
Like this.
Yeah.
Yeah.
I sub 2. And this is 2J. And we have one more thing, and that's 2 ohms up there.
Also, they're connected at the bottom.
Okay. And the question, what is I sub 1, I sub 2, V1, V2? Find all that stuff. Let me find the relationship between V1 V2 quickly. It looks like the polarity is backward here. V1 to V2, since it's backward, that's negative. N1 to N2. which is negative 1 to 2. So you can rewrite that as negative V2 equals what? 2V1, or V2 equals negative 2V1. Now notice the current I sub 2, they're both entering the dot, right? If I sub 2 is going this way, that means coming from here. They're both entering the dot. What's the ratio of I sub 1 to I sub 2? If they're both entering the dot. Negative N2 to N1, which is negative 2 to 1. So that tells me I sub 1 equals negative 2 I sub 2. And that's my second equation.
And those are not affected at all, even though the circuits are actually connected physically.
Well, I sub 1 is defined right there. If it was this one, it changes because that current is different than this current. Now, so these still good. If I know what the current through this, I'm in good shape. I'm thinking actually source transformation right here. Combine it with this, move it back up there, make my life easy. Notice if I look at the circuit right there, I can actually do a source transformation right here, and that will give me a voltage source of what? 10 divided by 2, 5. Oh, not a voltage, current source. It's going to give me 2. Another 2 up there, there, and the rest of it, I don't have to do the rest of the circuit, you know? There's the rest of the circuit goes up there. I don't really care about that. I'm not interested in it yet. That doesn't change. I'm looking at this piece right here. This will go in parallel with this one. 2 and 2 will make it what in parallel? 1. Product over the sum. Looks like this, the circuit. So this is the rest of the circuit. I'm just lazy. So I can do one more source transformation right here. And now my circuit will be what? 5 volts. So here's my circuit. 5, 1, V1, 1 to 2, there's my dot, I'm going to connect that resistor up there. Okay. And again, my equation is still good. I still know that V2 equals what? Negative 2V1, I have it. And I sub 1 equals what? Negative 2 I sub 2. By the way, this is V1 right here. This is V2 right here. What's the current going that direction? This is I sub 1. This is I sub 2. So what is the current going that branch there? I define it going that direction. It's called I sub x. Isn't that V1 minus V2 divided by 2?
Oh, V2 minus V1?
Well, I define it going that way. So this one minus that one, this voltage minus that voltage divided by 2. And what's this current here? KCL, it says that's I sub x plus I sub 1. Current entering a node equals the current leaving that node. What's this current coming down here? I sub x plus I sub 2.
Is Ix the current?
Going this way.
Okay. And then that. Okay, yeah, I see.
That's V1 minus V2 divided by 2. So if I do a KVL, this is loop 1. If I do a KVL here, this is loop 2. Let me do a KVL here. KVL, loop 1. Negative 5 plus this times the current through it, which is what? I sub x plus I sub 1 plus V1 is equal to 0. 5 equals, there's V1 plus 1 times that. Let's replace I sub x by its value, which is what? V1 minus V2 divided by 2 plus I sub 1. That's a 5, or 5 angle 0. Now if you want, you know what V2 is equal to? Negative 2 V1. See that? V2 is negative 2 V1. So if you plug it in, V1 negative and negative plus 2 V1 over 2 plus I sub 1 plus V1 equals 5 angle 0. 3 divided by 2 is 1.5 V1. And plus another one here, how about 2.5? So I'm cleaning this side, this equation, and that's my final product for it.
It's 2.5, right?
Correct. Now let's do a KVL right here. And hopefully I can come up with an equation that has V1 I sub 1 in it, so I'll have two equations by two unknowns. KVL, loop 2. Let's go right there. Minus V2 plus 2j times I sub x plus I sub 2. I know V2 is equal to what? Negative 2 V1. So minus a minus, I'll make it what? 2 V1 plus 2j times I sub x, which is V1 minus V2 divided by 2 plus I sub 2. What's I sub 2? Isn't that I sub 1 over negative 2? Because I'm trying to make it one equation by one unknown. And the only thing still in my way is that V2. But V2 is equal to what? Negative 2 V1?
So
That'd be 3 over 2. Yep. That's 1.5 V1 minus 0.5 I sub 1 2v1 plus, what's that? 3j? This will be minus what? 2 times 0.5 is a 1, that's j, I sub 1. And there's my second equation. If you clean it, 2 plus 3j v1. I forgot what the question was. What was the question? Find I sub 1, v1, everything. Yep. Equals j I sub 1 if you move it there. If you divide by j, three j over j, that's 3. 2 divided by j. J on the bottom will make it minus j on the top. And that's what that equation gives me. Anytime you divide by a j, that's equivalent to multiplication by negative j. So now I get two equations by how many unknowns? 2 unknowns. This is one, and this is the other one. Can I solve them? Sure. So let me put my equation here on the next page. The first equation I have, so I don't have to flip back and forth. v2 equals negative 2v1. I sub 1 equals negative 2i sub 2. Next equation, I sub 1 equals 3 minus 2j times v1. And the last one is the one 2.5 v1 plus I sub 1 is equal to 5 angle 0. I should be able to solve that by doing a substitution here. 2.5 v1 plus, in place of I sub 1, let's put 3 minus 2j v1. 3 and 2, that's what? 5.5 minus 2j v1 equals 5 angle 0, which means v1 equals, let's see what my calculator says, 5 divided by 5.5 minus 2j. 0.854 angle roughly 20 degrees. If I know v1, can I find v2 while I'm at it? Right here. v2 is negative 2 times v1. So multiply the answer by negative 2. 1.71 angle negative 160. Can we find I sub 1, I sub 2? Well, I know I sub 1 is 3 minus 2j times v1. We know what v1 is. So here we go, 3 minus 2j times I sub 1, times v1, which is 0.854 angle 20. 3.07, 08 actually, angle what? Negative 13.7. And can I find what I sub 2 once I know I sub 1? I sub 2 from this equation, it's I sub 1 divided by negative 2. We know what I sub 1 divided by negative 2. It is 1.54 angle 166.3. Do these answers match? So let me read the answers and you tell me if they match. ISIB 1, 3.08, angle negative 13.7. Yes. ISIB 2, 1.54, angle 166.3. V1, 0.85, angle 20. And V2, 1.71, angle negative 160. Good. Just to show you how the polarity is sometimes positive, negative quickly, I saw a picture in this book. And it depends how they attach the wires. Notice, for example, if they take this core here. Can you see that picture? Look at the wire here. If they want plus to plus, plus on the top, plus on the bottom, they can do that actually by going like this, taking the wire, wrapping it here. When it comes out of this, continue wrapping it here. Enters from the top, exits from the bottom. Enters from the top, exits from the bottom. Or they can take these guys, basically tie them together, and these guys tie them together. That's what they did right here. Notice if they take these and tie them together at the bottom, so they're going to have the same voltage. And the top tied together. You can do that.
So when they're tied together, is that the same problem we just did? Is that what that means?
No, the top piece, no, nothing to do with that. This is just like the wire, the wrapping with the wire there, you know. So you can reverse them. I can actually make this one attached to this. You know, I can reverse the direction of them. I can attach this to this and this to that. I can connect them anywhere I want to. If I attach to this, you know, and I can attach these guys together, I can make the current come into both of these, entering the dot here and make them exit both of these. So you can play with them. They can make them look. Do you have any other pictures? Not really. Just really looking at in the street there, transformers. That's what you and I see. That's your transformer right there. And again, we can make the voltage increase, we can make the voltage decrease. How? We can make the current increase, we can make the current decrease. It's the ratio, when you look back here, V2 to V1. It's the number of turns. Where is it? That's the better one. Before I get to that. Yep, right here. V1 to V2 is the number of turns. So I can make, it depends what I put for a number here. If I make this value higher than this, then you lower V2. If I make the ratio 2 to 1 here, notice here V2 is 2 times V1 because the number of turns here is bigger than this. That increase the voltage here. I can make it decrease by reversing that, putting more coils on this end than that end. That will decrease. That step down, you lower it. You can either increase the voltage or decrease. It depends on these ratios. I can make the ratio here 1/2 of this. If I make it 1/2, then V2 will be negative 0.5 V1. Or V2, yep, negative 0.5 V1, half of that. Or I can make it bigger. If I want to make it 3 times that number, make the ratio 3 to 1 here. Make it 4 times that number, make the ratio 4 to 1. So you can increase that. That's stepping up the voltage or stepping down the voltage. So we call them step up transformer, step down. I can either increase them, I can decrease them, or it depends on the number of turns.
Without retirement board Friday, excuse